Hi everyone, it's another day for learning and relearning things. Welcome once again to FSH Ed for another lecture on chemistry. It's me again, Mark Cortez, your chemistry and physics module creator for FilSciHub. Today we'll be talking about one of the laws fundamental to chemistry, the law of conservation of mass, which sometimes is also called as the law of conservation of matter. Now for the sake of consistency, we will be interchanging these two terms, mass and matter, for this module. Now this topic is for grade 10 students for their fourth quarter in science. Now before we head on to our lesson, let's take a look at the bigger picture. Kung bakit at kung ano nga ba ang dapat natin matutunan para sa module na ito. Our content standards for the students is to have an understanding of the chemical reactions associated with biological and industrial process affecting the environment. So, bali, bago natin tingnan ng mga iba't ibang chemical reactions, kailangan muna natin syempre suriin at intindihin ang characteristics o properties ng ating chemical reactions. By taking a look at the law of conservation of mass, mas maiintindihan natin kung bakit nga ba ganito natin isulat at tignan ang mga chemical reactions. And for our most essential learning competency for this module, it is to be able to apply the principles of conservation of mass to chemical reactions. Tulad nga na nasabi ko kanina, ang pag-intindi natin sa law of conservation of mass or matter ay maaari magdulot sa pagkakaintindi natin sa mga chemical reactions. Okay? In order to relate the law of conservation of mass or matter to chemical reactions, we must first have an understanding of chemical reactions, specifically these topics. So parts of the chemical equation. Ayan, ano ang mga parte ng mga chemical equations? Types of chemical reactions, ano ang iba't ibang uri ng mga chemical reactions? So let's go through them briefly. So for the parts of the chemical equations, there are basically three parts of the chemical equation: the reactants, products, and the arrow, or how we read this as yields. Para sa example natin, mayroon tayong dalawang molecules ng hydrogen gas at isang molecule ng oxygen gas as our reactants. So the reactants are usually found at the left side of the equation before the arrow. So the arrow, on the other hand, determines the direction of the reaction, or as what we commonly read as yields. It tells us which side is the reactant and product side. So reading the equation, we have two molecules of hydrogen gas and one molecule of oxygen gas yields, yan. So sinasabi ng arrow kung saan papunta ang ating reaction, which is towards the product side of our equation. So our product for this example is two molecules of water as gas. The product or products is or are usually found at the right side of the equation. Now, we also know na dapat ang mga chemical equations such as this ay dapat balanced. Balanced equations should show the same number of elements in both sides of the equation. Actually, we can find that the balanced nature of chemical equations is rooted from the law of conservation of mass. Makikita natin na kaya balanced equations ang ating ginagamit sa mga equations dahil sinusunod nito ang law of conservation of mass. Actually, yun na nga po yung lesson natin eh. Joke lang. Huwag muna kayong aalis. Ngayon, balikan naman natin ng mabilisan ang mga chemical reactions na ating i-relate sa law of conservation of mass later on. So the different types of chemical reactions and their general forms are listed below: combination, decomposition, single replacement, double replacement, and combustion reactions. Now, I won't be dwelling on the specifics of these chemical reactions, but Miss Ivy, or what I call Ate Ivy, also one of the creators of modules for FSH Ed, was able to prepare a module for this earlier this year, which you can view and access through the link below. Or you can visit it in our website in FilSciHub.com. The module walks you through the different chemical reactions and suggests some activities and examples and simulations as well, which you can use as practice for recall. Okay, so let's head on to our main lesson proper. So, what does the law of conservation of mass, or sometimes matter, actually say? it states that the mass in chemical reactions are neither created nor destroyed. Or in other words, or in terms of matter, matter is neither created nor destroyed in chemical reactions. Ibig sabihin, sa isang chemical reaction, hindi daw maaaring madagdagan o mabawasan ang dami o ng matter or mass. So we have Antoine Lavoisier, our main contributor to the law of conservation of mass. So he is a French scientist who carefully and repeatedly conducted different experiments on sealed glasses and jars while measuring their masses. So he conducted po yung mga experiments nga in sealed containers such that he could still measure the mass of the gases for the different chemical reactions that he conducted. So paulit-ulit po yun. And he observed that the mass of the reactants before the reaction were the same as the mass of the total mass of the products after the chemical reaction. Okay, in order to understand the law of conservation of mass, let us first apply it to an actual and common chemical reaction. Okay, so can you tell me what object is depicted in the image in the screen? Ano po ba yung nandyan sa screen nyo ngayon? So, yes, it is wood, specifically campfire wood. Okay, so sa Pilipinas, usually kahit ano namang kahoy, ginagamit natin pang siga o pang sunog, ayan. So, but if you were to light it up, kung sisiliban natin tong kahoy, we will most likely have this end product. Okay? Or we will observe this as an end product. We'll have ash or abo. Now, initially, if I ask you to compare the mass of the campfire wood, itong ating mga kahoy, and the mass of the remaining ash, ng ating mga abo, we will see a great difference. But the law of conservation of mass states that in a chemical reaction, such as the burning of wood, mass can neither be created nor destroyed. And initially, isipin natin na nawala or nasira yung ating matter. Kasi nga, look at the image, di ba? From a pile of wood, naging ganito na lang siya kaonte. Okay? But in fact, for this chemical reaction, we also have to consider the other products. So, hindi lamang po yung ash ang product ng ating chemical reaction. We also have to consider the gases produced. So, kung parang uulitin natin tong experiment na to in Antoine Lavoisier's method, somehow, makukuha natin yung gases niya. Kung kokolektahin o makukuha yung bigat ng gases na na-produce in this reaction, which is water and carbon dioxide, and add it to the mass of the remaining ash, we will actually get the same amount of mass as the starting mass. Okay? So let's put weight, or mass rather, into our example, just to give in order for us to visualize it more clear. So kung kunwari bago natin sunugin yung mga kahoy, atin itong tinimbang, and we got 1 kilogram as its mass. Okay? After natin sunugin yung kahoy, kinuha natin lahat ng abo nito at tinimbang rin, at ang nakuha natin ay 0.1 kilogram. Ngayon, if we made a setup where we could have gathered and collected all the gas it produced and weighed it, according to the law of conservation of mass, ang total mass nun dapat ay 0.9 kilograms. So, disclaimer lamang po, hindi ko naman po sinasabi na ganun talaga ang proportion niya naturally. So, this is just for us to visualize yung law of conservation of mass. So, yung proportion po ng weight ng ating gas at ng ating abo ay not necessarily consistent sa other experiments. Ayan. So, because in every chemical reaction, mass or matter can either be created nor destroyed. They can be transformed into different kind of matter, but essentially, it would have the same components and their mass would be the same. So, just to have give us a clear picture on how it is transformed, let's have another example. Okay, combustion of methane. So now let's use the combustion of methane, CH4, as another example for our discussion. So again, according to the law of conservation of mass or matter can neither be created nor destroyed. Using this example, mas makikita natin on how matter is transformed, redistributed, or rearranged into new or different matter instead of being destroyed or created. Okay? So in the equation shown, we see methane, CH4, reacting with oxygen to produce water and carbon dioxide. Based on the equation, we can see that both sides of the equation would have the same number of atoms of carbon, hydrogen, and oxygen. So basically, it's a balanced equation. The only difference is that they were quote unquote redistributed or rearranged into different compounds, from methane and oxygen to water and carbon dioxide. We can simply see that there was no change in number of elements and both sides had the same amounts of atoms of elements involved. Wala namang nadagdag na nitrogen or chlorine all throughout the reaction, di ba? Carbon, hydrogen, and oxygen lamang ang mga elements involved. So, we can therefore visualize chemical reactions as the rearrangements of atoms and bonds, while the number of atoms involved in a reaction remains unchanged. So let us use this example to further understand how does the law of conservation imply the mass of our reactants and products. Okay, so for potassium hydroxide, KOH, readily reacts with carbon dioxide, CO2, to produce potassium carbonate, K2CO3, and water, H2O. Now, how many grams of potassium carbonate are produced if 224.4 grams of potassium hydroxide reacts with 88.0 grams of carbon dioxide? The reaction also produces 36 grams of water. Provided also below is a balanced chemical equation, but actually in solving these kinds of problems, we don't really necessarily need our balanced equation, but it is a good practice to write our balanced equations. But the tip here is that just always have to remember the law of conservation of mass, which is mass is neither created nor destroyed in a chemical reaction. So what we do is we simply list down the mass of our reactants and the mass of our products. So, alam natin yung reactants natin ay yung carbon dioxide and potassium hydroxide. So, we put in one side 88.0 grams and 224.4 grams. And alam natin na yung hinahanap is yung potassium carbonate. Diba? So, we label it as X, our variable, and H2O, which has 36.0 grams, water as our product. Or as one of the given products. So we put potassium carbonate and water, the mass of these, into one side of our equation. So mass of reactants is equal to mass of products. So 88.0 plus 224.4 grams is actually 312.4 grams. And in our equation is equal to X, the mass of potassium carbonate, plus the mass of water, 36.0 grams. Okay. And in order to find X, we subtract 36.0 grams in both sides, okay, of the equation, and we get 312.4 grams minus 36.0 grams is equal to X, or the mass of potassium carbonate. And if we answer that, we get 276.4 grams. Now, in order to check, we can substitute again X to our original equation. The value of X to our original equation. So 88.0 grams plus 224.4 grams, which are the mass of carbon dioxide and potassium hydroxide as our reactants, equal the mass of our products, potassium carbonate, 276.4 grams, and water, 36.0 grams. Now, if you see that, check both sides of the equation, we solve them that they are actually equal to 312.4 grams. So if we get the same amount for both sides of the equation, we know that we got the right answer. Okay? Kasi nga, again, the law of conservation of mass or matter states that mass in a chemical reaction is neither created nor destroyed. Okay? So for our supplementary materials, so here is a link to a video by Ted Ed. titled The Law of Conservation of Mass, as explained by Todd Ramsey. So it is a video explaining the law of conservation of mass and relating it to the matters and their mass that make up the universe. So the video actually zooms in into smaller reactions, but also zooms out into the universe and how the universe started and how matter can be found in the universe. Okay. For our next supplementary material is actually a website. So this website provides an extensive discussion on the relation of conservation of mass to the different biological systems in our planet. So the web page is titled The Conservation of Mass by Robert W. Turner. The link is provided below. And actually, you can see here that the different chemical reactions that take place in the different environments and scenarios affect the surrounding environments, and matter as being rearranged can lead to different reactions or changes. So it provides different biological systems such as ating mga watersheds, how chemical reactions or the conservation of mass can be seen in farms, so in our animals and in our other different biological processes. Okay? But before we head to our problem set, let's take a look if we were able to meet our most essential learning competency for this module. So were we able to apply the principles of conservation of mass to chemical reactions? Surely, yes. As we have discussed earlier, following the law of conservation of mass, we create balanced chemical equations. And also, by understanding the law of conservation of mass and having a balanced chemical equation, we can identify the mass of specific components of our equations given data on the other components. As what we did kanina sa ating example sa potassium hydroxide and sa methane. Okay? As for our content standards, our supplementary material on the conservation of mass by Robert W. Turner help us take a peek into how do our chemical reactions and the conversion of mass affect our environment and life. To further meet this standard, watch out for the next module next week. Okay, for our problem set. Okay, for our problem set, our first question or our first sample problem reads 8 grams of hydrogen reacts with some oxygen to make 72 grams of water. Figure out how much oxygen must have been used by applying the law of conservation of mass. So again, as I have stated earlier, these kinds of problems do not necessarily require us to use balanced chemical equations. And we can simply remember this equation: mass reactants is equal to mass products. Or to be more exact, total mass of reactants is equal to the total mass of its products. So we just write in one side of our equation the mass of our reactants and the mass of, and in the right side, the mass of our products. So for this problem, we write 8 grams, the mass of hydrogen is given by the problem, plus X, so the amount or the mass of oxygen needed, equals 72 grams of water, or as provided by our problem. And we try to solve X. So by subtracting 8 grams to both sides of the equation, we get 64 grams. And again, to check, we just simply substitute the value of our X to our original equation, which is 8 grams plus X is equal to 72 grams, and check if both sides of the equation show or give us equal values. So 8 grams plus 64 grams is actually equal to 72 grams. So we know that 64 grams of oxygen must have been used to react with hydrogen to produce 72 grams of water. Okay. Next. So this one is a bit more tricky and requires a little bit of analysis. But again, we really won't be using balanced chemical equation. So let me first read it. A thin strip of iron with a mass of 15.5 grams is placed into a solution containing 21.0 grams of copper 2 sulfate, and copper begins to form after some time. The reaction stops because all the copper 2 sulfate has reacted. The iron strip is found to have a mass of 8.5 grams. The mass of copper formed is found to be 8.60 grams. What mass of iron 2 sulfate has been formed in the reaction? So again, we just have to keep in mind that our equation is provided by the law of conservation of mass. Mass reactants is equal to mass of products. So we have to first identify ano ba yung ating mga reactants. So, and ano ba yung mga mass nila. So for this one, we have the mass of iron and the mass of copper 2 sulfate as our reactants, and the mass of copper and mass of iron 2 sulfate as the mass of our products. Okay, but we have to keep in mind that the given masses for iron is actually yung ating starting mass of 15.5 grams and our remaining mass of iron, which is 8.5 grams. So to get the mass of iron, so we have again our initial mass of iron 15.5 grams, final mass of iron 8.5 grams. However, these masses are not the mass that we will be using for our equation. Okay, so to get the mass of iron used for the reaction, we will be subtracting the initial and the final mass of iron. So this problem also introduces the idea of limiting an excess reactants or reagents. Okay, so yung ating excess dito ay yung iron strip. Okay, so we have an excess of 8.5 grams. So in actuality, the reaction only used 7 grams of the iron for the whole chemical reaction. Okay, so now substituting it to our equation, so we have 7.0 grams of iron plus 21.0 grams of copper 2 sulfate is equal to, so yung mass of reactants natin, again, mass of iron and mass of copper 2 sulfate is equal to the mass of copper, which is provided by the problem, which is to be found 8.60 grams, plus the mass of iron 2 sulfate, or yung ating unknown or variable x. And again, we just simply simplify our equation. So 7.0 grams plus 21.0 grams is equal to 28.0 grams equals to 8.60 grams plus x. And again, to find x, the value of x, we simply subtract 8.60 grams to both sides of the equation, and we get 28.0 grams minus 8.60 grams, which gives us the value of 19.40 grams. So again, to check, we just simply substitute the value of x that we got to our original equation. So 7.0 grams plus 21.0 grams is equal to 8.60 grams plus 19.40 grams. So both equations, or both sides of the equations rather, equals to 28.0 grams. So it simply follows the law of conservation of mass, which is mass of reactants is equal to the mass of products. Okay, so our sources for the discussion of conservation of mass and some of our sample problems were actually sourced through freakgenie.com. So the link is provided there. And also you can access more sample problems there. And they also provide a short GDocs quiz on the law of conservation of mass. And that's all for today. Thank you again for listening to me. I am once again Mark Cortez from FilSciHub Ed. And I hope to see you next week for another module on chemistry.